This is the final solution, no surprise. The user sends a message to the API gateway that is the middleware. And then we have an AI-based filtering. If the question is good, we go on and we merge the new question with the chat history. This kind of merging helps GPT in solving a problem. Then the standalone question is sent to two different models. The first one on the bottom is basically the knowledge base. So we send the standalone question through, embedded using OpenAI EDA, and we retrieve from the knowledge base the top K that are most similar to the question. So we have the top K documents, and then the standalone question. The standalone question and the documents will go into the answer generator, and then in the end we have a module dedicated to validate the question, and then we do some other checks. Today I would like to share with you something about conversational agents, generative AI, but something a little bit different from what has been mentioned as of now. In particular, I would like to spend some time in sharing with you how we deploy, how we put in production this kind of solutions, this kind of algorithms. I work as senior AI engineer in BAP xTech, that is a center of excellence in BAP, a consultancy firm, Italian firm. I would like today that when you go out from this room, you have something useful for your work, for the way you develop your software, the way you put in production your software. So please feel free to reach out to me to LinkedIn, to Twitter, ask me for clarification, ask me for pieces of code, ask me to deep dive into what we do. It will be a pleasure for me. Just a few words on BAP xTech. As I mentioned, BAP is a consultancy firm, but I come from xTech, that is the center of excellence in BAP. I'm not here to do marketing or advertisement. It's just a quick overview. We are technicians, so we are very focused on hyperscaling technologies like data science, artificial intelligence, cloud solutions, and software engineering. We are spread all over the world, Italy, UK, US, and we are partner of Google Cloud. So that's all. Let's start with the use case. I would like to mention a real-world, a real-life use case because I think that is simpler to understand what I'm going to say with a real-world use case. In this use case, we developed some weeks ago a solution for a telecommunication company in Switzerland, a conversational agent to solve a problem. The problem was that their IT service desk was overloaded because they have 4,000 users, 4,000 employees that are not very technical. They are not very good in installing software, solving issues, even connecting the PC to internet. And this is why they open a lot of tickets, a lot of support requests to the IT service desk. They are overloaded, and we proposed to the client to implement a conversational agent to solve the problem, to basically drive the user step by step in installing a simple software or requesting the purchasing of a specific license and stuff like that. In particular, the client has to install the solution on Google Cloud Platform, to use Microsoft Teams as chat UI, because they don't want to introduce a new conversational interface in their ecosystem, and everything powered by OpenAI GPTs. As you can see, we have a lot of requests each day. We have a massive amount of users. Okay, so we have to deal with this kind of limitations. And this use case is very simple, but we have an iceberg use case, because you see the top of the iceberg that is implementing the conversational agent. So I can write a few lines of code with the long chain, plugged in GPT, providing about 70 documents to GPT and answer users' questions. But there is the part under the sea that you don't see. That is, for example, you have to connect a solution to a specific UI, so you have some limitations related to Microsoft Teams, and later we will see how to deal with. You have to deal with also OpenAI. They have GPT-4 that is very powerful, but there are some rate limits. There are some limitations in the number of calls that you can make to their APIs. You can request quotas increase, but you cannot go with huge numbers. So basically, we have to define a real-time architecture, because you cannot answer in 1 hour, 2 hours, 3 hours. You have to answer to those issues in a very quick way. You have to handle a massive number of interactions, because we have 4K users that can at the same time make the same question or different question. You have to ensure data privacy. We are talking about a global company. So they manage a lot of important data. They are placed, their headquarters is Switzerland. They manage a lot of conversation banking data. So they would like to be sure, they want to be sure that no one in the company can write in the chat something that must not be disclosed to the public, or something that is sensible. Okay, they don't want to share this data with OpenAI. And in the end, you have to provide a cost-effective architecture. You have to provide a scalable architecture. If your architecture does not scale up or scale down, your cost will rise a lot, because we have 4K users. This is the final solution, no surprise. I know that the text is a little bit small, but I can quickly comment on that. So basically, the user send a message. Power Virtual Agent is the interface between the Microsoft Teams and the Google Cloud Platform. Send a message to the API gateway that is the middleware. And then we have an AI-based filtering that basically determines whether the current question from the user is good. If the question contains bad words, inappropriate content, or stuff like that, we refuse the question and we answer with a standard answer. If the question is good, we go on and we merge the new question with the chat history. So basically, we create a standalone question that is, let's do an example. The user has a problem with the VPN, okay, and can write, can you help me in restoring VPN configuration, okay? And after the merging with the chat history, the standalone question could be, the user is asking to restore the VPN configuration, and the same problem was experienced 1 month ago, and the solution you suggested is this one. And yesterday has a similar problem with the network and another problem with the connection to the Adobe server, okay? So we have a standalone question summarizing the user status. This kind of merging helps GPT in solving a problem. Then the standalone question is sent to 2 different models. The first one on the bottom is basically the knowledge base. Later we will discuss about knowledge base. Basically, the knowledge base contains the 70 documents that I mentioned before. So we send the standalone question through, embedded using OpenAI EDA, and we retrieve from the knowledge base the top K, top 1, top 2, top 3, top 5 documents that are most similar to the question. So if we are talking about VPN, probably the top K documents are related to VPN. So we have the top K documents and then the standalone question. The standalone question and the documents will go into the answer generator. And in this case, we ask GPT for the following question. Can you answer to the standalone question of the user using only the documents extracted without adding any information from your background knowledge? This is the question we do in a very simple way because the real prompt is a little bit more complex. And then in the end, we have a module dedicated to validate the question. So we use, for example, semantic validation. We call again the knowledge base, and we check that the content of the answer is contained in the knowledge base. We want to be sure that everything sent to the user is contained in the knowledge base. And then we do some other checks. So this is the architecture, okay, from the logical perspective. Very simple, something that we already discussed probably in the presentation before me. So very simple, but as I mentioned in the previous slide, there are some aspects that must be considered when you want to move this solution in production. Here we are using mainly serverless solutions from Google Cloud. So we are using Cloud Run, Cloud Endpoints that are serverless solutions to run Python scripts. We're using a Firestore that is a serverless database from NoSQL database from Google. The most important choice from the architectural perspective that you can make here in this kind of architecture is the VectorDB. Because the VectorDB contains the 70 documents that I mentioned before, and you must be sure that the technology that you are selecting is the right one with respect to your use case. And today I would like to share with you what we learned in the last few months about VectorDBs. There are three main aspects that you should clarify to select the best vector database for your use case. The first one is, should I go for a managed service or for an open source solution? The managed service, for sure, is has more scalable capabilities, is more production ready, but on the other hand, we saw that the possibilities to configure the database are less than the open source ones. So, for example, if you need a particular similarity function, or if you need a particular multi-threading configuration, or if you need something special to handle in memory on disk trade-off, probably with the managed service you cannot do that. So you have to decide about this point. The second point, privacy and data loss prevention. As I mentioned before, is an important aspect in enterprise level use cases. So if you want to encrypt your data, probably the managed service is not good for you, because most of them are outside your cloud platform, resides in the data farm and data factory of the cloud provider. And in the end, the scalability and production readiness. Okay, if you go for an open source solution, you must be sure that your database, your technology can scale up and down, can support Kubernetes, can support Docker, or other architectural, infrastructural, container-based solutions. And in this case, we went for Quadrant because the use case is not complex, but we needed some customizations, and yeah, so we went for an open source solution, because the most important aspect is that we had to encrypt the information contained in the documentation shared by the IT service desk. This is the most important aspect. So now we defined the vector DB that contains our documentation, and now we can focus on a more generative AI related aspect, that is the prompt engineering. Too often we are focused on the words that we put in the prompt, but we are not focused on how we build the prompting strategy. In this case, we have a message that goes through a set of prompts, okay? For example, the first prompt could be the prompt dedicated to understand whether there are bad words or not. Or the last one is the one that generates the answer, okay? And you have to optimize the journey of the message, of the information through the prompt, because since you have a massive amount of users, 4K users, you must be sure that your message goes through the minimum number possible of steps. Okay, so for example, you can use a router prompt that selects the best next action, and according to that, you can define a default exit rule to skip everything when you are not confident with the answer, or whenever there is something that is not working. You must define a default exit way, so that you can save some money, because you don't perform some prompts. In this way, you can also define some more complex routes, because probably the line in the middle is the route that is used the most of the time, and the 2% of time that you go through the complex case, you can put 1, 2, 3, 4, also 5 prompts, because you know that you go there only 2 times, but you want to be sure that when you go in the complex case, you are doing well, you are obtaining the answer. So what's important for me to share with you today is that when you design a generative AI use case, you should consider also the prompt pipeline and not only the content of the prompt. In this use case, we saved more than 60% of API calls to OpenAI, and considering that we have 4,000 employees, we are talking about a good amount of money. Then we have another important aspect, that is the caching system. If you already answered to a specific problem in the past, why you have to generate again the answer? Okay, so in this case, we implemented a caching system that checks whether there exists an answer, and if it's yes, we skip the answer generation. We skip all this prompt pipeline, and even in this case, you can avoid to call OpenAI, and you can save other money. Okay, here we put some KPIs to demonstrate the benefits that we measured. We measured those KPIs in comparing the development environment with the production-ready environment. And these numbers are very interesting, considering that we are talking about 4K users. If you imagine that ChatGPT is served all over the world with a lot of millions people, you can imagine what is behind ChatGPT from the caching system, but also from the prompt pipeline engineering perspective. And there is another aspect that we can optimize, that is the interaction with GPT. We cannot reduce the cost. We cannot reduce the performance of the model, but we can change the way we interact with the model. As I mentioned before, we have 4K users, a lot of queries. So probably we quickly run out the quota limit, the rate limit that OpenAI serves to the users. We are a multinational company. We have a direct interaction with OpenAI, with Azure, with Microsoft. They increase our quotas, but after a certain level, they cannot go. So two possible limitations are these ones. You can perform load balancing cross-region, so you can initialize endpoints in Sweden, UK, Switzerland, okay? But also you can perform model level load balancing. So the most stupid questions, the most silly questions can be sent to GPT 3.5, so that you can save some money. Or if you know that some prompts are very simple, you can send them to GPT 3.5 that can perform well, and also from the cost perspective is lower with respect to GPT-4, and also the quota limits is higher than GPT-4. So if you combine a region level load balancing and model level load balancing, you can reach 10 times availability, about 10 times availability with respect to using a single endpoint with a single model. I don't know if this is legal, but okay. And there is one last step that we can optimize, that is the output filtering. Since we are we are dealing with a global company, we must be sure that the answer is correct, because if the user performs the wrong procedure or do something that is not good, probably there are some other more important issues. So we have to validate what the agent is given back to the user. For example, as I mentioned before, we should validate that the content of the answer is contained in our knowledge base. So we must be sure that if we are talking about VPN, everything about VPN is contained in the knowledge base. So we call the knowledge base when we generate the question, but also when we validate the question. For example, we should include in the prompt engineering some content guidelines. We must explain to GPT how to answer and what to answer and how to answer, okay? And we should also perform some intent recognition. We must check whether the user is trying to hijacking our solution. And there are some other important checks that we should perform. For example, the fallback mechanism. I already mentioned something before, but even in the output validation, you need a fallback route, because if your answer is not valid, you have to provide something to the user, because he asked something to you. So you need a fallback mechanism. And last but not least, we already explained how to deal with OpenAI, that is an external system with respect to what we implemented. But another external system is Microsoft Teams, that is exposed to the cloud platform through Power Virtual Agent. And also with respect to Power Virtual Agent, there are some limitations. And this is a common case at the enterprise level, because when you start a new project, even the development of a new digital asset like this one, probably you have to integrate what you develop with the existing ecosystem. So you have to deal with this kind of limitation. And there are some important, in this case, Microsoft Teams has a lot of limitation. You have to, for example, deal with the response timeout. Microsoft Teams requires wants the response within 20 seconds. Okay, and if we see the architecture, we perform two queries to OpenAI, so we have a latency. We have a query to ADA. We have a query to the knowledge base that is a vector DB, so takes some time in giving back the top K documents. So if you do some calculation, some math, you can see that we are about 5, 6, 7 seconds on average to answer. So, but if you have to optimize your pipeline in order to deal with this timeout. You have to deal with data anonymization because your data must be optimized before they are sent to OpenAI. So you have to mask the name of the user. You must check the content because if they put something related to the business, you have to mask it. And when the answer goes back to the user, you have to restore the original content. Okay, so you have to deal with this important aspect. We are talking about procedures. So message formatting is very important. If you have images or hyperlinks, you have to put them in the answer. And in the end, you have to deal with when the user starts to write multiple messages like we do on WhatsApp. What happens when the user sends more messages? You provide more answers, but if the user splits the question over more messages, how can you deal with? So this is something that we faced and we implemented in our solution. And as you can see, these steps are not related in a specific way to generative AI. But as you can see, without these four crucial, let me say crucial points, your solution probably won't work or is unsecure, or you can lose your data, your important data. So yeah, this is something not very strict to generative AI, but very important when you go in the production environment. So this is the final solution again, and that's all.